Good afternoon. A warm welcome to 105th episode of Creative Online Talks. Today's topic, exploration of planetary bodies, Moon and Mars. It is an absolute pleasure to have each one of you here today as we continue to the celebration of creativity, innovation, and knowledge sharing. I am Supriya Nayaka, your host for the session. Creative is a group of people who are like-minded and curious to gain new knowledge. Cre means creativity, active means activeness, to be active, we need creativity. Knowledge Square is our tagline. Sharing of knowledge increases our knowledge. Vision of Creative is to build constructive thinking on various domains. Our focus on non-textual, non-academic, non-syllabus related concepts. Every Saturday, we organize online talks on Zoom platform and we live stream our program on Creative GBD. Creative is thankful to all our resource person for engaging us with their knowledge. The moon, our ever-present celestial companion, has fascinated humanities for millennia. Its luminous beauty has inspired poets, artists, and dreamers throughout history, while its mysterious have challenged scientists and explorers to uncover its secrets. Today, we stand at the forefront of a new era of lunar science, where groundbreaking research and space exploration missions are revealing unprecedented insights. Over the years, Mars has been a focus of intense scientific interest and exploration. Numerous robotic missions, including rovers and orbiters, have been sent to study its surface and gather data about its geology, climate, and potential for past or present life. These missions have revealed fascinating insights. Mars also holds the promise of future human exploration. Our speaker will share this profound knowledge, experience, and the latest advancement that have transformed our understanding of Moon and Mars in this talk. This talk is not only an opportunity for us to gain knowledge, but also a platform for interaction and collaboration. We encourage all the participants to engage actively, ask questions, and share your thoughts with our esteemed speaker. Let us welcome our eminent speaker, Dr. Vijayan S. for today's session. I welcome you, sir, and I welcome all the participants for today's session. I call Divya, creative volunteer, to introduce today's speaker. Over to Divya.
Thank you, ma'am. Good afternoon, one and all present here. I am Divya, volunteer of Creative. I am here to introduce our today's chief guest, Dr. Vijayan, working as an assistant professor at Physical Research Laboratory from 2015. He completed his MTech in remote sensing from 2005 to 2007 from Anna University, Chennai, and he completed his PhD in remote sensing from 2008 to 2013 from Anna University, Chennai. His PhD research work is to understand the lunar surface process, and he completed his postdoctoral at Physical Research Laboratory from 2013 to 2015 from Ahmedabad. And Vijayan's major research area is to understand the role of impact craters in the evolution of planetary bodies like Moon, Mars, Mercury, and icy bodies. And he got Young Scientist Award in 2018 from Indian National Science Academy, and he got Career Development Award by Lunar and Planetary Institute (LPI) from USA in 2010, and he got a Senior Research Fellowship in 2010 to 12 Council for Scientific and Industrial Research. And he has guided several under and postgraduates and currently guiding PhD and postdoctoral students. And this is all about our chief guest. And I am welcoming you, sir, for this session. And I am welcoming all the participants of Creative. And I am welcoming volunteers of Creative. And I am welcoming Supriya ma'am. Thank you, Supriya ma'am, for giving me this opportunity.
Thank you, Divya. Over to you, sir. Sir, you are not audible. Your voice is not. No, sir. No, sir. No.
Hello.
Now it's.
Yeah.
Yes,
Okay.
sir.
Yeah, I'm just sharing my screen. I'm sharing my entire screen.
Yes, sir. It's visible.
Yeah. Okay. Just minimize all the things. Okay. I hope my
Yes.
screen is visible.
Yes, sir. Yes, sir.
Yeah.
Go
And
ahead.
I thank you, the organizers, for providing a chance for me to interact with young minds, and I'll try to best to inspire the people. And my name is Vijay. I do research in physical research laboratory. I do work in the planetary sciences division, and the today's topic is exploration of planetary bodies like Moon and Mars. You people might have heard about a few lectures about Moon on previous talks and on Mars. So what I thought is I'll give you a glimpse and few important features or the geological event that occurred on these two planetary bodies. So the first half an hour I'll try to talk about Moon, and the last half an hour I'll try to talk about Mars. Overall, in between, I'll try to compare whether what is the relevance between studying these planetary bodies and how we can interrelate with Earth or with the other planetary bodies. The title is exploration. Okay, the exploration means it is to explore or understand about these planetary bodies. Why only these Moon and Mars? If Earth stretches its hand, Moon and Mars is the closest body, and that's another reason. Like I'm more interested in these two planetary bodies, and they are close neighbors to Earth, and they provide a vital information that this body is completely absence of atmosphere, whereas it has a very thin atmosphere, whereas our Earth has a very ambient atmosphere. So this gives, two bodies near to Earth are completely different. So the exploration starts with the understanding of the own plan, the Moon and the Mars, and how it helps to understand our own Earth. So moving forward, I'll start my talk with Moon. The This is the only body where we got some samples. Okay, now I have to change this phrase, like, because and now we got some samples from some asteroids also. So we got, but we didn't get it kg. Still, the statement holds good. And the key information is like these. I'll just show the pointer. Okay. So the moon is hypothesized to form from one of the big impact that happened on the early Earth, and that created the moon. In that case, the moon is one of the ejected material that came out from the Earth itself. So this is the one relevance people started exploring, like whether the moon and Earth are similar in the past, or how it evolved, or how it varied. So the exploration started from moon, and that leads to give a clue, like there is a probability that it has found from the early Earth. To move forward, how do we see the moon? This is the near side of the moon, and this is the far side of the moon. You guys might have seen this during night several times. And this is the far side of the moon. The striking difference, between these two planetary bodies is like these two sides are the dark features which you are seeing, the mare deposits. These are the volcanic flow deposits. Whereas this side it is relatively less. Only in these few places we are seeing. So this itself a quest, like why this quest is still unanswered, or people are trying to answer it. Why the near side of the moon has a dominant volcanic activity, whereas the other side doesn't have it. So this is one research problem. It was going from Apollo era or till it is going on. The people are so interested to find the striking difference. These things. In the talk, I'll be mostly concentrating on a feature that is called impact. The circular things, whatever you are seeing on this screen, whatever circles you are seeing, they are called impacts. Like, yeah, an asteroid or an object from outer space came and hit the lunar surface and formed the circular features. So this is called an impact. On night, even on Earth, we may see some shooting stars, like stars falling from the skies. When such objects come and hit the surface, it will form a depression, and it will form these kind of impacts. But luckily now the solar system evolution has saturated. We will not have these many big impacts. We'll have only very small, very micrometeoroids only will come and hit the surface of Earth. And moving forward, so this is the same lunar surface, which is, instead of in a circle, if you project it into a equirectangular or a rectangular projection, this is how you see. Now you can see the distribution. This is the volcanic deposits. They are concentrated on only in this part, whereas here and here they are sparsely distributed. And all the circles which you are seeing are the impacts, the one which I showed. So I'll give a more detailed info about that. Okay. The same lunar surface, if you see it on the elevation data, like with respect to height, this is how it will appear. See, these are the surface where in the earlier slide I showed the volcanic deposits are present. Now you see they are at low elevation. The shades of blue are relatively lower elevation than the shades of yellow, green, and white. So the near side of the moon, this is the near side of the moon, they are having less elevation, or their surfaces got altered drastically, whereas the far side of the moon, which you are seeing on the left side of and the right side of the screen, they host large number of impact craters, and which suggests they are relatively older terrain, which not got modified as much as the near side of the moon has modified. So this itself says there is a geological evolution of the moon is different from the near side and the far side. And the one of the biggest impacts I will show about, but I'm just recalling the circles. What we are seeing are all impacts. The bolide which came from the outer space and strike on the lunar surface and form these big circles. There will be few tens of meters to hundreds of kilometers in diameter, whereas their depth will vary from, again, few tens of meters to at least a few kilometers. So one big basin is on the South Pole. So this is on this side, and this is on this side. I'll be showing some examples about that. And to move forward, so now this is the dominant surface features on moon, and not only on the moon, and almost all the planetary bodies. So have a quick look about that. Before that, I'll just show how the lunar surface temperature varies. This is again the same lunar surface in the equirectangular projections. You see, this is the equatorial region. So the equatorial regions are warmer, where the temperature can go up to 400 Kelvin. Whereas if we move towards pole from equator, you see this is the South Pole. The South Pole, the temperatures are 50s, or plus and minus 50 kind of thing. So this is very cool region. So if it is very cool, then we can anticipate some volatiles. So that volatiles are ice, and that's what most of the missions are targeted towards higher latitudes. And the There are a lot of studies which they want to understand how the temperature variation and temperature related alterations are happening on moon. That leads to understand whether how the weathering process is happening and how the overall some of the older surface which I showed on this part of the moon, they are exposed to at least 3 to 4 billion years for surface temperature variation. So there will be a lot of weathering activity happening over this part of the moon, mostly in the equatorial part. Whereas in the polar regions, you can see in the North Pole also, there are very cool regions as well as in the southern regions. So these are the current most interested areas to look forward, apart from the moving towards 60 and 70 degree of sun. And as I said, I'll just tell one brief info about impacts, like what is an impact and how do they form. This is how they'll form. Okay. Just go back. Yeah, so the bolide came and hit the surface, it formed a bow, the material has been thrown out, and the surface is growing bigger and bigger. The material is still thrown out. The thrown out material will go and fall far away from the surface. This is the rebounds effect, where the surface will rebound and form a small peak. So once again, how it forms. So you can see it keeps on growing. Now, this is the final bow or the depression which I showed in my previous slide, the circles which we have seen. Now, all the circles are formed by this way. So there is an individual bolide coming and hitting the surface. So there will be a shock wave effect, there will be melting of the rock, there will be excavation of material from the surface, there will be thrown out of material with very high velocity, and they can move as much distance as far. I told that this is the diameter of the crater where I was mentioning. It will be from tens of meters to hundreds of kilometers. Some are even thousands of kilometers. So one crater will be the size of the India from Kanyakumari to Kashmir. Such a big impacts are there on the moon. If such a big impacts are happening, now we can understand what kind of extreme condition that planetary body will undergo. So this will alter that place like anything, and that is most interesting part. And events are more on moon. How much? So this is the answer. The one which you're seeing on the screen, or the craters which has been mapped from the lunar surface. So there's a person, Roberts, 18, in 2018, he published this work. Approximately 2 million craters are there on the moon, whose diameters are greater than 1 kilometer. So he just mapped those craters which is having the craters which are just trying to move this out. The crater size are much bigger. You can see it's a very big circle. This is roughly 900 kilometers in diameter. This is more than 1,000 kilometers in diameter. And the 2 million count does not include craters less than 1 kilometer. If you count that, this will go some 5 million or 7 million. There is no study done yet, or there are some studies ongoing to understand how small the craters, how much numbers of craters are there. So when such processes are happening, we can anticipate how much drastic changes will undergo to the surface. It brings a lot of things. For example, in this crater, what you are seeing is the impact and the dark surface of the magma material which came after the impact-induced fractures on the target surface. These impacts will create a lot of fractures on the lunar surface, and that will bring the magma from deeper surface to deeper part to the surface. That's why we are seeing it over here. The same scenario holds here. Exactly the same scenario holds here. The darker ones are the magma which came from deep inside to the surface after this impact through the fractures that got induced. Now, if in the previous animation I showed, when the impacts forms, materials will be thrown out, and that will be in a very high velocity. This is the one which I showed in my previous screen. So this is the one I'm showing in the next screen. So this is the one. It's around 900 kilometers in diameter, and the materials are thrown out here. You can see a linear chain of craters oriented in this direction. These are formed due to the material thrown out from during this impact process. You can see the arrow indicates the chains. So one of the studies which says that there are 30 to 40 such basins. The basins, impact basins, are theoretically defined if their size is greater than 300 kilometers. And this is one of the youngest basin on the moon, which is around 3.8 billion years old. So how many secondaries were formed from this impact? When this big impact formed, the material thrown out and punctured and formed all these craters, which I'm showing on the screen. Roughly 2,700 secondaries are formed. And how the diameter varies, you can see this impact is forming 10 kilometer, 15 kilometer, 20 kilometer, 25 kilometer craters. That much big craters they are forming. And the peak is at around 7 to 8 kilometers kind of thing. So this bigger is forming 1% size of the impact, or 10% of the size of the impacts all around this region. And the extent goes, the scale says it is 300 kilometers, so this will be roughly around 900 kilometers kind of thing. Now you can see how much spread it has. So this is the example from one impact basin. Now, if there are 30 to 40 impact basins, now we can imagine how much impacts are formed on the lunar surface. And this is one stat which gives that if there are 30 basins on moon, then we will anticipate 81,000 of craters formed from these 30 basins. So one impact, this big impact, is creating 2,000 or 2,000 plus kind of thing. So it's contribute to 5% of the probably the 5% of the impacts are due to the secondaries, and they are formed by such bigger basins. As a zoom out view, you can see the scale. It goes around 10 kilometers. So this impact is greater than a 10 kilometer, and it is easily distinguishable. It will form in a chain of events. This is one-time process. During this formation, everything form. The materials are thrown up and they are aligned radially to this big impact. That's what we are seeing here, a big fringe or the continuous chains of craters. Okay. Now, if these are the number of craters present, then if someone wants to land on moon, then how difficult it could be, or how much understanding is required. Like, it is not even on Earth to land an aircraft. We need a perfect runway, and the runway should be clear. Then only the aircraft can land. But now think about moon, and for example, consider an ellipse of 15 by 8 kilometers. So in that, the number of craters which mapped is 23,000. So within this 15 by 8 kilometer, we are having 23,000. Suppose this is a landing thing. We want to land within this ellipse. Where do we land? It is so complex. There appears like there is no flat surface here to land it. That's because the moon is highly impact crater. So what these impacts will do means they are excavating the lunar surface, and they are providing us the subsurface material thrown out to the surface. So if you want to go and explore moon, the impacts are already digged the subsurface material and thrown it outside. So the outside materials mostly contains of the subsurface materials. So such a complex terrain was there on the moon. That's what it is challenging to land on the moon. And this the density, the crater density, it's going to vary from place to place and from latitudes to longitudes. This is it's just a zoomed in view, like to see. Now it looks like somewhat clear. Yeah, there appears to be somewhat flat surface than the previous screen, but you look at the scale. This is a very small scale, and for the notice, there are many small craters that are not mapped. So still, if we map all such small craters, then the screen will be full of yellow circles. It will be. Now it's more challenging, and so for finding a flat surface or a near flat surface for the land. Though the scale is very small, it is still tricky. And in the impact crater slide, I have shown when this impact forms, they will have a small depressions. The depressions will vary to this to their diameter size. For example, you can see this crater. It casts a long shadow. So the sun is almost in the southwest direction. That's what, if it is deeper and it is steeper and it has a raised wall, that's why it will cast a long shadow. Whereas this one has a very faint shadow. This one, very faint shadow. So that means it is not as, this is the deeper one, and this is not that much deeper. This is a simple thumb rule where we can anticipate about how deeper the craters could be. But we have the elevation data for each and every region on the moon that also contributes. So this is a glimpse, like wherever we land, we will be exposed to the impacts. The same impacts are there in the polar region, but they have a different striking difference. As I showed in my temperature slides, the temperature around the polar region is roughly 50 kelvins or plus or minus kind of thing. So that means they are the colder parts. If they are colder parts, they may host volatiles. And it is already observed there are the water ice deposits present on the polar regions. So if they say the water ice presence on the polar region, they are present on these craters, not on the surface. On such craters, they are mapped. So these craters are known permanently shadowed region craters, PSRs. That means these craters, except this part of the crater, the entire crater will not receive any sunlight at any period of time. That means for the few, after that formation, like few millions or billions of years, this part has not received any direct sunlight. That means it is colder and colder, and that makes the things for to preserve the volatiles which has been there. So this is one map which shows about the presence of such PSR regions on the south pole regions of Moon. So these are the regions, they are widespread, and these are the targets for the future missions to go and explore such PSR regions on the Moon. Yeah. It is, if we anticipate water ice within these PSRs, whether there are layering there is one study by Selene, and they have explored the shallow part of the Shackleton crater, exactly located on minus 89 degrees south. When they observed it, the surface of this crater, that means this crater surface, that is this one. They look appears normal. They have only regular particles, regular materials. So where is the volatiles? Where is the water ice? The water ice are embedded on the pore space of those regoliths. They are not on the surface. They are embedded within the pore space. Within the loose sand materials, that is usually called regolith. This is another area where it is confirmed by a mission called L-Cross, where it impacted the all of the instruments flow over this part, and they impacted over the PSR region, And there is a follow-up instrument which came and measured there is the presence of volatiles because of the previous impact. The plumes came out and that got measured from the follow-up mission. So this is one region on the moon where there is a sure shot evidence for presence of volatiles. Yeah, we do some studies on that. So this is a crater called Amundsen, just around 87 degrees south. It's a big crater around 80 plus kilometers in diameter, and you can see there are several PSR regions present. However, these are the sloped walls. They have a very steep part where it is difficult to land or climb, whereas this is one part of the region, and these are few potential regions where they are on the near surface. If you look over this part, how the surface looks like, as I showed in my previous slides, this is how the surface looks like. The PSR regions, they still host some impact craters and all. This got obtained from MAC data with different SNR. So this region also used pyroxenes over there. So coming to the last part, so the ones which I showed are all occurred on the earlier epochs. That means they may have formed from a few billion years ago or a few hundreds of million years ago. What is recently happening on Moon? So the one and almost the one event that occurring on Moon is the impact. Like how we on night we see the shooting stars coming and impacting the surface. Look at this part in this image. So A, we don't have anything, but on B, there was a small circle formed. This is an impact. This is not here. This is in another place. So this study occurred using the NAC data up to 2015, and they found a number of craters. These are the craters which formed very recently. Apart from this, the very recent activities are very less or almost nil on the moon. So yeah, small wind up, like the moon, mostly composed of volcanic material. They are dominant by impacts. Some places volcanic and impact and volcanic materials are co-occurring together. And these impacts are occurring today also, but they are occurring in the very small size. So this is a short intro about Moon. Now, if I move towards Mars, in Mars also, I will try to link with comparing to the impacts only, but I will give a glimpse about how it was 4 billion years ago, how it was 3 billion years ago, how it was 2 billion years ago, how it was last 1 billion years, and how it is today. So moving on to the Mars. So this is the one of the again the elevation map of Mars. What is a striking difference on this is yellow shades of light. This is the region which separates the Mars into two halves. It's called lowland, and this is called the highland. The reason is, you see the elevations, they are 0, -1, -2, or -3 kind of thing. Whereas if you go in this part, they are in plus scale. Okay, so this part is higher, it's called as highland, and this is called lowland. And the striking feature on Mars is Mars hosts some of the biggest features on the solar system. This is called the Olympus Mons. You see this number 21249 meters. That is exactly somewhere here, and it's called the tallest volcano on the solar system. And this is called the Valles Marineris. This is known for the largest opening on the planetary body. The entire length from here to here, from this part to this part, it is roughly more than 2,000 kilometers. And it is 2,000 kilometers in length and nearly 4 or greater than 4 to 5 kilometers depth. Such a large opening. And this one is the circles as showed on the lunar part. These are the impacts base. This is roughly 2,000 kilometers in diameter. And this circle is also an impact. So the Mars hosts biggest volcano, biggest canyon, some of the biggest impact basins here, and one of the largest lava flow volcano over here, and it it has undergone undergone uh, ice ages like what Earth has undergone. That's what this picture shows, that the early Mars means the 4 billion years before, probably covered with ice at not one, at multiple times based on the obliquity variation. So this is the short intro about Mars, and moving forward with this, I'll start with the 4 billion years. As I said, 4 billion years. Now, at 4 billion years, Mars is very much volcanically active, and there are a lot of volcanism that happened in 4 billion years. That is during the southern highlands. Whereas the preservations of volcanoes on the southern highlands are high, whereas on the northern part, where it is low elevated, it is almost it is very. So one study showed that impact on a volcanic dome has exposed what kind of lava material was there within these volcanic domes. Whereas on Moon, I have shown within that impacts the magma came and filled up. Whereas here it is in the other way around. There was a volcanic dome and the impact punctured it and exposed the subsurface of these volcanic domes. So in a nutshell, I want to say, you see, this is the dome. You see the elevation. It varies roughly around 1.5 kilometers. After this, after the impact on this part, this got dropped up, and this went like this. So that is drawn here. So now we are seeing what is present within the dome. That's what I told in my earlier slides. The impacts are exposing the subsurface material over there. So if you want to explore any planetary body, the one place is to get into this crater. That is one of the reason. Like some of the Martian rovers which are roving, the Curiosity and Perseverance, they are exactly within the crater floors. So you will get lots of information about the subsurface of the planetary bodies and the further alteration. We do within that volcanic zone. We do see orthopyroxenes and we do see olivines. So that means the earlier Mars are having olivines and orthopyroxenes, and they are got exposed from this. But it didn't came exactly with that alone. It has a lot of sand deposits. So after this impacts and all, there are process of, as I told, that the Mars was covered by ice covers. So the ice covers were in the entire Martian surface, even in these surfaces, the ice was covered at one point of time, and they got melted and they formed different fan channels, and they led to give evidence for volcanic, fluvial, glaciers, and all sorts of things. So this is one place where such things is hosted. It is there. So this is the region where the ice got deposited and melted, and the ones which you are seeing are the channels. And the channels came here and it formed a fan deposits. So those fan deposits are purely sedimentary in anything. So this is the evidence where we can see what was there on Mars. And their presence is around 3.5 billion years around that time, 3.5 to 4 billion years kind of thing. And you can see a number of channels, and this channel is associated with the fan deposits. If the ice is depositing, and then similar thing is where the Perseverance rover is exploring, where there was a channel and there was a delta deposits. So this is the rover, now there it is going over there. These are the evidence where this channels associated landforms are potential targets or to explore the subsurface of Mars and to see how the alterations happen over the surface. The same exists on Earth. That's what we'll try to relate it. This is one example from Tambora volcano in Indonesia. See, this is a volcano, and and on the floor, you see water was there, a lake, small lake, the fan, eroded materials forming the fan. Here, the source for water is precipitation, whereas in the previous slide, I have shown an examples for ice melting driven landforms. Whereas the same do exist in other parts of the world also. This is Herbert volcano is closer to Canada, northern part of Canada, or in the Canadian surface. It too hosts a volcano. When the volcano is not erupting, it will host water. If the water is there, there will be erosions from the side walls and they will form a deltaic fan deposits. Such deltaic deposits are there on Mars. The one which I showed in the last few slides are same scenarios that have occurred on Mars. On Earth, we are seeing it, but on Mars, it formed around 3.5 billion years ago. There is not much major geological activity. That's the reason these things are still date preserved. Again, at around 3.5 or that time, we do have a lot of impact, and the impact generated a lot of, and they accumulated a lot of snow over the elevated surface, or you can see the contours. Over these surface, the snow got deposited, and once they got melt, they will form a channel, and the deposits are deposited on the bottom side of this impact. So craters with channels and deposits are the primary targets and primary evidence for the presence of past water activity on Mars. This thing have not eroded even after 3.5 billion years. It is still preserved the typical fan-shaped deposits, that is, if terminology called in the sedimentary thing. So these are the evidence. However, within the same thing, we do see some preserved sinusoidal channels, and at the termini of the channels, we do see some fan deposits. These are this is a kind of meandering channels what we do see on Earth. When the river is getting older, they'll try to get meander, and they'll try to have deposits over there. This is one sort of not meandering. It is taking the leads to slope. That's what it started to form a sinusoid kind of pattern. It is tending towards that. So this is one of the best examples for such. Water has flown and deposited the sediments on the Martian surface. The darker ones are the dust, which is hindering the observations, all the darker parts in this image, whereas the line-like features are the one consist of coarser materials, whereas the rest are eroded because the rest are finer materials. They got eroded in the last 3.5 billion year time scales. The wind was eroding those things, and they removed it. Yeah, more observation. Yeah, one peculiar observation that this fan is coming over this part, whereas this fan is coming over this part. So they are orthogonal to each other. You can see the arrow indicates they are going in this direction, and this arrow indicates this direction. So what it infers that there are two probable sources of water activity. That's what these channels are going in almost east-west line, whereas this channel-driven sedimentary deposits are going from south to north, and they are getting overlapped. That also indicates this is an older fan deposits. This is a relatively younger fan deposits. However, it is tricky to decipher what is the time difference between these two, because of the large number of erosion that has occurred over there. This is the eroded surface. These are the one eroded. These are the one eroded. The same, I do the channel form in the last two slides, which I've shown the channel. The channel is exactly over here. The channel is over here. And now you can see there is a mountain. This is the rebound, which during my previous slide, impact slide, I showed. At the final stage, there will be a rebound of mountain. This is that rebound mountain, and we do see a lot of channels over it. Again, the material skin, the volatiles or ice or snow got precipitated over here and they got melted over time and they formed these channels. The last slide where I showed a sinusoid channel is exactly here, but we couldn't able to see because there is a dark dust deposit that got mantled over this entire region. That hinders the observation to say there is a fluvial activity occurred over here. These hindrances are throughout Mars and they are widespread. Around 3 billion years, there is another water activity, very less probability over there at that time because it has to be a catastrophic event. There was a large fracture called Graben that got punctured probably due to this impact over it, and the water below the subsurface started coming out and started forming these channels. You can see as so it breathes at two places. That's what we are seeing, two channels, and here it got damaged. Now you can see this is a weather. It's an erosional channel. The reason is you can see a mid-channel island. This is the river. Even the same phenomena we will do see on today's Earth and on if you go and see rivers. In between there will be some small sand patch over it, the water will be bifurcating and flowing. The same phenomenon is observed out here. When they started observing the forming, this is getting eroded. The water was coming here. However, there is a coarser material here that got eroded by the water, and the water started bifurcating and flowing around this. The same or here, there is one more small channel. This is the one I was mentioning, exactly this one. So the water was going around this part of it. So this is one more evidence, like typically the water has carved the Martian surface, and it was written catastrophic because the time period which was mentioned here it's not much favorable for the surface water because it is anticipated around 3 billion years the surface pressure and temperature is drastically low within the Martian surface. The same example to show that these are the water channels which has gone and they have eroded the landforms. If you go from 3 billion years to like 1.5 billion years, this is one crater from the ISRO Mangalyaan MC's image. I have shown an example of largest canyon on Mars, which is extending for 2,000 kilometers, but they formed around 4 billion years. Whether such a big canyon formed at one time itself or they are forming at different time scale. That's the purpose of one of the study. So this one, what we are seeing, probably formed during 1.5 billion years ago. The reason is that indicates that the same activity which formed the 2,000 kilometers long canyon on Mars is still a small kind of activity was occurring in very recent time or 1.5 billion years ago. It forms this large opening. It is exactly closer to the valley which I showed, which is 2,000 kilometers long. Now you can see it. This is the one which formed 3.7 billion years ago. Yep. It's around 150 kilometers, whereas this opening on the thing is around 2.6 billion. So this event happened after 1 billion years. So that means the activity was building up, the pressure is building up over there to form this thing. That's what this represents. So the largest valley Marinaries formation, the large part of the formation is during the earlier epoch, whereas in very recent epochs, only very small scale catenas. The catenas are nothing but a long, narrow opening on the Martian surface. So, shown example for volcanic opening and all. There are evidence for Okay. There are evidence for glacial activities also. These are the end moraines where when the glacier was there, and when they go back, they will leave these marks. They are called the end moraines. These moraines are also observed on Mars. So Mars is completely different from Moon. Like they have water, they have glacial, they have volcanic, they have impacts, everything. More examples to show the craters are the bowl shaped one. The bowl shaped ones are the ones which good enough to trap the volatiles which are transported through the atmosphere. So this bowls, you can see some flow materials where the black arrow indicates. So that means some traps on this part of the crater has flown and formed these boundaries. You can see these boundaries, and these are the uh, deposits which are formed from the slow precipitation over this part of the things, and they are happened in the last 500 million years ago to somewhat plus or minus over that range. So that means currently activities, the glacial activities are occurring in the very recent past. Whereas if we go today, or what is it getting today, today no activities are happening, but there are some small cracks and fractures are exposing the subsurface water ice that are preserved on Mars. So this is one place on the Mars where we found this was a scar where the shades of whitish blue tints are the water ice, presence of water ice on Mars. Yeah, small opening on the surface or a small landslide kind of thing in general, if I call, that has opened up and showed the subsurface water ice. And these are the diagnostic spectra for identifying the water ice. They have a 1.5 and around 1.9 to 2 absorption, micrometer absorptions. And this indicates that the water ice was there. And this place, and this place, we observed it on 21st April 2012, and we observed on 27th April. So after a week also, there is still preservation of volatiles. That means it has not sublimed that much. So that means the volume of water ice that below the subsurface is huge. That's what it has not sublimed entirely over a week. That's the reason people are anticipating Mars is hosting a lot of water ice and it is habitable. Yeah, exactly. This is the reason. This is the water ice that has been talked about. And coming to today activity, today means it happened 1 year back, 6 months back, that also. These are the ones, the track. This is a slope crater wall where a rock, an individual rock has been rolled and formed this surface. So from here, the rock jumped here, jumped here, jump. So when it is jumping, it will disturb that surface, the black one or the disturbed surface. So that is called the boulder rolled induced ejecta. So it's called boulder fall ejecta. There is one single boulder coming from here, and wherever it after this point, it has jumped here, then it is jumped because it is rolling or down the slope. And these patterns are the prominent one where we can say that the current Mars, the today Mars, are happening on today's Mars. So that means what is the source for such an activity to happen? Because Mars has a thin atmosphere and it is a very good aeolian activity, and there is a very good probability for Mars quake, like earthquake. And another example where all this is a dust covered on the surface of the crater wall or a general wall. The boulder was rolling over here and they left this footmarks. And these footmarks are preserved for from 2 to 4 Martian years. 1 Martian year is to Earth year. So it is preserved from 4 to 8 years kind of thing. So if we observe such trails or any planetary body, then it is an indication that there was a very recent activity We call it today, either it is a week, year, or tens of years, or at least few decades old. This video was not playing. So there was a landslide in Kinnano, Himachal. I think I can show that video. Oh, sorry. I'm not advertising. So this is the boulder fall. You can see the jumping, the flying rocks. These are flying rocks, how they are disturbing. You see one flying rock. You can see this rock will be flying. See this one? How this will be few tons. And when it impacts, see the exactly. This is an exact screenshot from the video which I have shown. Even we credited these people in our paper. So now you have seen one rock was flying and crossing this tree and coming and breaking this. This is the one exactly happened over here. In this, it is seen it is only one rock or few rocks. In Mars, there are thousands of rocks that has been. This is one from Ladakh in the videos for there. This is from a snow-covered mountain. You see these tracks are from these waterfalls. And this study, this video is not running. Sorry for that. So what they did, this Cavis et al. They did a very controlled experiment. They just took a 1 ton rock to a Swiss Alps. This is 1 ton rock which say they took it through a chopper, and from here they dropped it, and it started rolling. From the video which I shown, it is something similar to that. So we're analyzing what this individual rock shape, size, weight, everything is doing to the surface. How we can understand the dynamics of such one single rolling rock and about the landslides and other activities. So that's the reason this study was being performed. So coming to the end of today, a recent activity, I showed a video like where such boulder trails has been formed. They are occurring on the today's Mars. And where do they are occurring? Large number. On Earth, if it is occurring, we know the reason is could be there may be earthquake, there may be a precipitation, there could be a landslide trigger. These are the reason. But on Mars, there is no precipitation. There is only wind activity, or that may be a Marsquake. One of the mission called InSight mission that has went to a region called Cerberus Foci, where this is a sloped wall where there are n number of such boulders as rock has fallen. So to move such n number of, I say n numbers means it is going to be 100 to thousands of such rocks of weighing from few tons or less than a ton. They have all deposited on the footwall. So the anticipation is there could be a Marsquake activity over this part. That's it is better it went with a lander and a seismometer to detect the quake activity. In this region, exactly in the Cerberus Foci region, we found that entire Mars of the boulder fall, 30% is falling within this region, and not only that, and they occurred very recently. I mean, today, a year ago, also it has occurred over this part of Mars. So that indicating this is one of the activities in Mars to understand about the subsurface activities. With this, I just summarize. So left is the moon and the right is the Mars. So if you understand about the moon, so the moon majorly witness the volcanic and impact activities. But those things are, so the bigger size of impacts and bigger size of volcanic activities are in the earlier reports. Whereas in the present moon, it is witnessing very small micrometeoroid impacts. It generates a few tens of centimeters to a few meters in size. Whereas moving to Mars, on past, the Mars witnessed volcanism, fluvial, glacial activities, and impacts all over the epoch. Whereas when the time migrates, suddenly the fluvial and glacial activities stop, and this volcanism also stop. And whereas the present Mars is mostly witnessing the aeolian activities like dunes, the gullies, yeah, the ice activities, and the boulder falls which I have shown. So both the bodies are saying that there are different sort of activities that occurred in the earlier epochs, but over their evolution, they have stopped, and their stop is still a quest, and they are not like that of our own Earth, whereas all such activities are even active today. So that means these planetary bodies evolution stop at certain point of time, but the Earth's evolution didn't stop. It is still ongoing. Thank you.
Thank you, sir. Any question? You can conversation. You can start asking questions. I am unmuting everyone. So you can unmute yourselves. Hi, Venkat. You want to ask any questions?
Yes, sure, ma'am.
Sir.
Yeah. Good afternoon slash good evening. That was an amazing presentation by you, sir. Thank you for your time, and it was also a wonderful event. So thank you, as usual, for Creative on organizing this session. I would like to know more on, apart from this volcanic activities, that almost all of these land-based rock planets that have existed, they have experienced this volcanic activities. So I would like to know a bit more about the decay in volcanic activities on Earth. Currently, there are a few mountains. As the evolution is going, you mentioned that it's sort of not ended. It is continuing to evolve into a separate planet like all others. We have experienced a lot of volcanic activities as well as volcanic decay. So, what is the similar relation to other planets that can happen, like on Mars?
Sir, you're muted.
Yeah.
Yeah, like Earth, there is no other planetary body which has a very active volcanism. But on Venus, the entire Venus is covered with volcanic flows. We have lava flows. The entire Venus, the Venus size is almost that of the Earth. But the reason for stopping of the volcanic activity over Earth, over the Moon and Mars is still a quest, to be honest. They didn't have the sufficient subsurface pressure to bring up the magma to the surface, or the activity is not that much to bring the magma to the surface and to create the volcanism. Whereas on Earth, it has still have a core. It's the dynamo is there, and whereas these bodies, they may be dead, and that could be one reason. But we don't know. We don't know. There is one satellite called Io, where there was very much volcanic activities. We don't know whether there is a current volcanic activities ongoing or not. Even we don't know about Venus. The one potential things apart from Earth we can explore, we need to explore or to understand is about Venus, because of the similar size to the Earth and large number of volcanic activities that has occurred over there.
Okay. Secondly, adding to your statement, with Venus, can we like mention its evolution is slower or faster with its volcanic activities?
On Venus, the volcanic activities are up to very recent times, came few 100 million years ago also. But the thing is, the number of missions to Venus is very limited. So we have some knowledge about it, but more has to be explored in detail, whether people are looking for whether any recent volcanic activity, because there is a very thick atmosphere over Venus. So it is very difficult to view invisible band like what do we see on Mars and Moon. So Venus may have, but it has to be explored in detail.
Got it. Thank you.
Thank you.
May I ask a few questions?
Yes, sir. Go ahead, sir.
I have two questions. One of them is that, is there any correlation between crater activity and volcanic activity, crater formation?
Okay.
One
so
thing.
now,
And secondly, one more, is there any evidence for life, past life or present life on Mars and Moon? Any kind of evidence? Since you mentioned that water was available in the past. Could you please comment on these things?
yeah. To answer your first question, I say the impacts, it's very difficult to say, or people are still working on whether the impact induced volcanism is there. But instead of that, what do we say, or even we do study, is when such a big impact happens, if there is a magma chamber few kilometers below, I have told that these impacts will generate a lot of fractures on the surface, means cracks. Whatever rock it is going to be there, it will generate cracks, and through that the magma will come and deposit on the surface. That's what I told. In the far side, there are some few volcanic materials seen within the crater. They are not induced, they are transported through the fractures and came into the crater. So that means the magma was already there. These impacts have provided a pathway or a channel for them to come to the surface. However, there is a caution that if the magma chamber should be below the crater and it should be in a liquid state so that it can float based on the pressure difference. This is the general opinion till date we have. And we do have 2000 kilometers big impacts also. But what that is generating is something different thing. So the impacts bring the magma material what is present below the surface. That's what we have mostly seen. And to answering to your second question, yeah, in Mars we do a lot of evidence for water activity. But the question is like to whether we found any life or biosignatures. Even everyone is interested to know about that. And even the last two rover missions, which landed within the Gale crater and the recent one within the Zero crater, they both landed and exploring the region where there was a very huge water activity. They are anticipating any sort of organic materials can be found, but till date we didn't have it. We have very high resolutions for Mars. Individual rock can be differentiated. If there are any fossils kind of things, so it would have been seen by this time. So in my views, it may be in microbial things which is not directly exposed, or there are hindrance by dust. The Mars is highly dust covered. Few meters of dust covers are there on Mars. So whatever you have of things that will be covered up. So the answer is like, it's an open question. We'll still have to search, but water is the one pathway where we can go and explore about the past life activity on Mars.
Okay, thank you.
Any more questions? Dinesh, sir? Sir, you can check your chat box. There is one question.
Okay. What's the scope for developing payloads by students? Like what are the fields may students can think for design or development of payloads? Okay. So the question is, what's the scope for developing payloads by students? Like what are the field may students can think for design and development of payload? The scope is like they'll get interest and they'll get motivated and they'll take up the planetary science. And what field is like, there are many fields. They can even develop a small camera, small rover, and or they can design an algorithm for the rover movement or detect a feature on it, or they can develop temperature sensors, um, or they can develop wind sensor. There are on Mars we have two temperature and pressure sensors, like a weather station. So one small weather station, two weather stations we have on Mars. It give daily temperature, pressure, humidity, everything. So this is one simple set of experiments where it can be deployed. Even students can do it. So that is one thing. Other things are small rovers. Nowadays there are so many options for rover development, and the rover is the design of rovers. I was looking some rover. They want a spider-like rover. Many are inspired by the natures. The specialty of the spider is it has a legs, so it can crawl over it. So some are developing a two-wheeled rover so that the stability can be there and it can climb on the slope surface. So these are the scopes for payload developments, and it depends on the student's interest.
Hello.
Yeah. Yeah, please.
Gunandan sir, go ahead.
Yeah, madam. Can you hear me, madam?
Yes, sir.
Sir, first of all, thanks for such an excellent presentation. I have two questions. One is a general question. Actually, since I've been studying about all these things, I was surprised when I came to know that moon is dead because it does not have any geological activity inside it.
Yeah.
But in the recent past, there are some papers, and suddenly the opinion has changed. If you go on the web, they say it is alive. So I want to ask you a general question: whether it is dead or alive, our moon.
Okay.
That's question number one.
Yeah.
And question number two: now Chandrayaan-3, we are landing on the southern pole region. Now, on one side, it is very popular in the news that it is a completely shadowed place and there is no sunlight. Whereas our rover and lander are supposed to work for 14 days in the sunlight with the sunlight. So kindly explain these two questions, sir.
Okay. The first question is whether this moon is dead or not. It's a relative scale. The people say dead means it is dead in the last 100 million years, 500 million years kind of thing. Yeah, moon is mostly dead. The recent work says there may be a very small volcanic activity. They say it happened 500 million years ago or 100 million years ago. In geological timescale, 100 million years it's a very small error. But for a human life, 100 million years is a very big term. Overall, if you see, I have shown in my slide the impacts, the micrometeoroids impacts are the one which are happening very recently, like last decade or last 5 years kind of thing. Apart from that, there is no major activity on moon. So we can call it as almost dead. Sporadically, it can happen, very sporadically. That's all. And coming to the second question, the rover is not landing in a very higher latitude. It is landed in 69 to 70 degrees south, and there we have good number of sunlight. So there is no PSR region like what I have showed in my slide. That is a very good sunlit area, and we do receive sunlight for the entire 14 days. So it will move very well.
Thank you, sir. Thank you very much.
Any more questions? Sita ma'am? Okay.
Sorry, I
Yes,
didn't.
ma'am.
Yeah. Thanks, Vijayan, for the wonderful talk. On the moon, based on the track of that ejected material, which goes on a straight line track, and based on the gap between the bouncing, etc., can you find any properties of that material? And then on the Mars, for example, you have talked about the flow of probably water several million years back. Is this water, or is this, as some people said, salt-like water. I mean, there was
Brine.
a few years back
Brine.
the thing that, yeah, there is no flowing water, but actually it's salt water. And is there any north-south variation of this flow and also of this boulder falling?
Okay. Okay. So the first question is about bouncing boulders difference. The difference between bones have any material properties or not. So this one will not change the material property, whereas it will expose the fresh surface. So if you do any mineralogical studies, it will be a dust-free region. So we can able to see what is there in the subsurface and we can understand about the mineralogy. So that is one part we can derive from the bouncing boulder part. Whereas it directly indicates whether there was a quack activity or what is the source for it. So that is the study what we can do it from the boulder fall kind of thing. Whereas in your second part of your question, like there is any difference in flow or brine's flow. The one which I showed is not the brine flow, that is the water flow that occurred 3 billion years ago. But there are brines flow. The brines flows are the salts which get precipitation or get when they get moisture, they will try to flow. But they are very thin veiny flows on the Martian surface. Yeah, they are, some of them are having a signatures of hydrated minerals. That's what people say. It could be a very thin water flow. But now there are more studies over it which says the current Martian pressure is 6 millibar and the temperature is very super cold. That means at that condition, the liquid water may not be possible. It should, even though it is a brine flow, it should be a very thin granular flows where that flows may contain some salts. That's the reason they are saying that. So now they are refining it. It is not exactly water flow. No, it can be a dry flow also, or it can be the brines, which is a thin veiny flow. But still, it's a question like how that it flow on the current pressure and the temperature conditions on Mars.
Yeah, and is there any north-south variation for this boulder falls?
Okay, this boulder fall doesn't have any variation within north and south. It has the only thing is the boulder should be weathered and it should be standing over the cliff or a sloped wall where a small shaking of ground or further weathering can trigger it. I did a global study on Mars. I didn't found any north-south variation. It is present in all the directions.
Thanks, Vijay.
Yeah, thanks, man.
Any more questions? I think we can wind up here, sir.
Okay.
We are running out of the time. Okay, thank you, Vijayan sir. Thank you for accepting our invitation and giving your time for us. Thank you for all the information you have given. Thank you once again.
Yeah, thank you.
Thank you one and all for joining us. Thank you, sir.
Thank you, ma'am.
Bye-bye.
Yes, sir.
Thank you, Venkat.